Today we are talking about the mean value theorem, one of the major theorems of calculus. Calculus being all about slope and rates of change. So we'll get into the nitty-gritty of it in a minute, but the main idea is actually pretty logical. So I would just ask you to think this. If you're driving in a car for an hour and you average 50 miles an hour over that 1 hour trip, doesn't there have to be at least one time during that hour when you were traveling 50 miles on the dot? Maybe it was for several seconds, maybe it was only for an instant if you sped up to go past 50 or slowed down, but if you average 50, you must have been traveling 50 at some point. And that's the main idea of this, really, is that whatever the average rate of change of a function is over a particular interval, there must be at least one time in that interval when the instantaneous rate of change is equivalent to that. And here's a visual of that. Here's a function, and this is a secant line connecting 2 points on the curve. The slope of that secant line is shown here as being 0.47, and I can move these things around and the slope changes with it. It's a very cool little demo here on GeoGebra. And that slope, the slope of that is the average rate of change of the function over this interval from a to b. So there has to be a time between a and b when the instantaneous rate of change, or the derivative, or the slope of the tangent line, has that same slope value. So here's just a little visualization here of a tangent line to this curve, and I can drag this along, and there should be at one point, notice the slope being displayed at the top there, there should be one point when the slope of this tangent line is exactly 0.41. And you can probably visualize it would be right around here. I'm getting close to it, and you can see it's 0.46. I went by it a little bit. There it was for a second. I saw it. There we go. And of course, that means they are parallel at that point. But notice C does not have to be halfway between A and B. There just has to be somewhere in that interval where that tangent line slope is equivalent to the secant line slope, where the derivative is equal to the average rate of change. And of course, you can change it, but there's still going to be at least one time, if not several times. And if I make the interval, big enough here, then there'll be multiple times. There's one right around in there, and then there'll be another right around in here. But there has to be at least one, and that's the main idea. And so now we're gonna explore it with a function and do some calculus. But I just like that visual first, to be able to see it and understand the concept before we go just throwing equations and numbers around and setting things equal and randomly hoping you come up with the right answer. It's good to have a goal of what you're trying to find. So here we go. Let's transition back and do some algebra, or calculus as it were. So look at that transition there, kids. So now we're going to do a problem from start to finish for the function f of x equals 6 root x plus 1. Determine if the mean value theorem even applies over the interval 0 to 9. And if so, find the value of c guaranteed by it. So there are a couple conditions which need to apply in order for the mean value theorem to apply. One, the function must be continuous over that closed interval. So is this function continuous over the interval 0 to 9? Definitely, right? It's 6 square root of x plus 1. Its domain is x is greater than or equal to 0, and you can see the graph here. So it's definitely continuous. So that condition is met. And the other condition is that f must be differentiable over the open interval 0 to 9. Now, you have the graph in front of you, so differentiability, it's got to be nice and smooth, no vertical tangent lines, no discontinuities of any kind, no cusps. And I think you can see that it is differentiable, but you don't always have the graph in front of you, and you might not always know what the graph looks like. So to determine differentiability, remember you're essentially doing the domain of the derivative. So if f of x is 6 root x, or 6x to the 1/2 plus 1, then its derivative would be 1/2 times 6 is 3x to the negative 1/2, and that will be 3 over root x. And you'll notice that f prime is defined as long as x is greater than 0. And that's where this open versus closed interval on the conditions is actually important, because this function is continuous at 0, like it does exist at 0, but it's not differentiable at x equals 0, right at that one spot. But it does not need to be differentiable at 0 because it's not including the endpoint for its differentiability condition. So it is differentiable over the open interval, so the mean value theorem does apply. And now what does it actually say? Again, it's about that average rate of change must be equal to the instantaneous rate of change somewhere in this interval. The AROC must equal the IROC. The slope of the secant must equal the slope of the tangent. So let's find that average rate of change here by doing what is f of 0. F of 0 is 1. What's f of 9, the y value at the end of the interval? That would be 6 times square root of 9 plus 1. And that will be 3 times 6, 18 plus 1. That's 19. And you can see that on the graph here. There's 0, 1, and 9 comma 19 is right there. So our average rate of change over this interval is the slope of that secant line. 19 minus 1 over 9 minus 0, or 18 divided by 9, which is 2. So the average rate of change, or the slope of that secant line, is 2. Okay, so now there must be a spot in this interval where the slope of the tangent is exactly equal to 2. So we find the derivative, which we've already done. It's 3 over root x, and we set it equal to this average rate of change. We find out when do we have a slope of 2. So we set 3 over root x equal to 2, and we just solve this little algebra here. You can swap these, and 3 halves equals root x, square both sides, and you get x is equal to 9/4. And 9/4, or 2 1/4, is certainly within the interval. If you get multiple x values on future problems, just make sure they're all in the open interval, which this one certainly is. And 9/4, or 2 1/4. 2 1/4 would be right about here on the graph if you want a little visualization. And that tangent line slope, you can see just even from my crude sketch, looks pretty parallel to that. Looks like it has the same slope. So there we go. So the value of C they are talking about is 9/4 if you want to be official there. Okay, hopefully the mean value theorem is making sense from an algebraic and a visual standpoint. And as always, keep working, kids.